Explorer 1 proceeds with its astonishing endeavor through space, perfectly transferring vital information from the most distant areas of the universe. For nearly 50 years, this marvelous space probe has altered our perception of space. The spacecraft, on the other hand, has recently been transmitting alarming information back to Earth, leaving the entire space industry in shock. These disturbing signals have raised questions. Are they the result of a technical malfunction, or could they suggest that we are not alone? Are we joined by extraterrestrials? As we uncover the truth behind these captivating transmissions, we must consider that, since the dawn of history, experts have been fascinated by the mysteries beyond our celestial limits. This curiosity led to the historic launch of Voyager 1 and its twin, Voyager 2, remarkable missions in space. These groundbreaking missions, which had been planned for a long time, began with Voyager 2's launch from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5th of that same year, Voyager 1 followed. These twin probes, each weighing a substantial 720 kilograms, equivalent to a small car, were propelled during a one-of-a-kind alignment of the outer planets. Throughout their incredible journey, these bold explorers traveled in different directions and at varying speeds, leading to a crucial moment on December 15, 1977, when Voyager 1 overtook its identical twin due to differences in trajectory. Since then, Voyager 1 has become an invaluable asset, providing us with a plethora of information and helping decipher space-related mysteries. The Jovian imaging mission. Before we get into Voyager 1's shocking new discovery that stunned the entire space industry, let's take a look at the extraordinary images the spacecraft captured during its crucial Jovian imaging mission in 1978. At that time, Voyager 1 was positioned about 265 million kilometers from Earth. From this vantage point, it transmitted a stunning number of photographs back to Earth. In January 1979, it embarked on an exceptional 100-hour endeavor, capturing a mesmerizing time-lapse film showing 10 rotations of Jupiter. A collection of 3,750 pictures allowed us to observe the majestic dance of Jupiter in clear detail. In the following months, Voyager 1 navigated through the Jovian moon system, making a remarkable discovery: the presence of a faint ring surrounding Jupiter, along with 2 new moons. These findings further expanded our understanding of this fascinating planet. To ensure a safe passage and avoid a potential collision with Titan, a moon of Saturn, corrective maneuvers were executed. Voyager 1 continued its celestial journey around Saturn, revealing 4 new moons: Enceladus, Dione, and Rhea. The final mission. With the conclusion of the Saturn mission, scientists decided to end the Voyager planetary mission, sending both Voyager 1 and Voyager 2 beyond the boundaries of our solar system. Traveling through space at an astonishing speed of 325 million kilometers per year, Voyager 1 entered a new chapter in January 1990, the Voyager interstellar mission. During this phase, Voyager 1 captured some of the most famous photographs in history, immortalizing the Sun and most of the planets. One key figure in extending the mission beyond its initial objectives was the prominent astronomer Dr. Vasily Sands. As part of the Voyager imaging team, Dr. Sands strongly advocated for capturing one final set of images as a farewell gift to humanity. Against all odds, his unwavering determination paid off on February 14, 1990, when Voyager 1, positioned 6 billion kilometers from the Sun, began a visual journey that was dubbed the Planetary Family Portrait. These breathtaking images, totaling 60, added to the probe's remarkable collection of 670 photographs taken during its encounter with Neptune. Record-breaking discoveries. Voyager 2 achieved an extraordinary milestone by recording wind speeds on Neptune exceeding 13,100 meters per second, the fastest winds ever observed in our solar system. As the spacecraft ventured within 280,000 kilometers of Neptune, it provided remarkable insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was revealed to be one of the largest and coldest objects in our solar system. with surface temperatures plunging to a frigid minus 391 degrees Fahrenheit. Triton's unusual features, such as its nitrogen gas, erupting ice volcanoes that carried particles of frozen water 5 miles into its thin atmosphere, further captivated researchers. These extraordinary discoveries expanded our knowledge of the vast diversity and complexity of celestial bodies residing in the outer reaches of our solar system. Voyager 1's unsettling transmission. Voyager 1 and Voyager 2 were no ordinary space probes. They were meticulously designed with a spin rate over 50 times slower than the hour hand of clock. This design choice minimized visual blurring as the spacecraft captured data and images while moving through the vastness of space. Even before their encounters with the outer planets, their impressive imaging capabilities astonished both scientists and the general public. The spacecraft began sending pictures of Jupiter before even reaching the gas giant. These early images showcased Jupiter's wavy clouds and the well-known Great Red Spot. However, the real surprise came with the discovery of active volcanoes on Jupiter's moon, Io. Slightly larger than Earth's moon, Io turned out to be the most geologically active body in the solar system. The spacecraft's instruments detected unusual signals from Io, later confirmed by striking images of towering volcanic plumes and a surface scarred by eruptions. One of Io's most prominent volcanoes erupted with a force more than 100 times greater than Mount St. Helens, covering an area nearly the size of France. The mystery of Voyager 1's signals. Despite their astonishing longevity, the Voyager probes have recently begun transmitting puzzling information back to Earth, particularly Voyager 1. In May 2022, mission controllers at NASA's Jet Propulsion Laboratory, JPL, reported that Voyager 1's Attitude Articulation and Control System, ACS, was sending corrupted data. Instead of transmitting normal status updates, the data appeared random, distorted, or even meaningless. However, Voyager 1 continued to function normally, receiving and executing commands correctly. This suggested that the spacecraft itself was not in immediate danger, but that something had gone wrong with its ability to properly report its status. Possible explanations. Scientists have proposed several theories to explain these bizarre transmissions. 1. Software glitch or memory corruption. Decades of exposure to cosmic radiation could have corrupted Voyager 1's computer memory, altering key software instructions. 2. Hardware degradation. After nearly 50 years in space, some of Voyager 1's hardware components may be failing due to age. 3. Cosmic interference. Some researchers speculate that Voyager may first have encountered an unexpected cosmic event, such as a strong magnetic field or unknown type of radiation. 4. Extraterrestrial interference. While unlikely, some enthusiasts have speculated that the strange signals could be a form of interference or response from an unknown extraterrestrial source. However, there is no scientific evidence to support this idea. NASA's response and the future of Voyager 1. Despite these difficulties, NASA engineers have been carefully troubleshooting the issue, sending commands to the spacecraft and evaluating its responses. Since Voyager 1 is currently over, even as Voyager 1 and Voyager 2 approach the twilight of their missions, their contributions to science continue to resonate. Their extensive data sets have fueled countless discoveries, providing humanity with a deeper understanding of the cosmos. These spacecraft have transformed our knowledge of planetary systems, magnetic fields, interstellar space, and the boundaries of our solar system. Future prospects. How long can Voyager 1 last? NASA engineers have been carefully managing the remaining power aboard Voyager 1, prioritizing essential scientific instruments while shutting down non-critical systems. The radioisotope thermoelectric generators, RTGs, that power the spacecraft are steadily weakening, producing less electricity each year. By 2030, it is expected that Voyager 1 will no longer have enough power to support any instruments, effectively ending its ability to send data back to Earth. However, even after its instruments cease functioning, Voyager 1 will continue to drift through interstellar space indefinitely. Like a silent messenger from humanity, it will carry its famous golden record, a time capsule of Earth sounds, music, and greetings in multiple languages, intended for any extraterrestrial civilization that may one day discover it. Voyager 1's path beyond our solar system. As Voyager 1 moves further into interstellar space, it will continue on its journey toward the Ophiuchus constellation. Though it will take over 40,000 years to pass within 1.6 light-years of the next nearest star, Gliese 445, the spacecraft will remain a testament to human ingenuity, a relic of an era when humanity first reached beyond its solar system. The profound legacy of the Voyager program. The Voyager missions have redefined our understanding of space exploration. They have discovered active volcanoes on Io, revolutionizing our perception of moons as geologically dead worlds, uncovered the faint ring system of Jupiter, proving that planetary rings are more common than previously thought, captured breathtaking images of Saturn's intricate rings, revealing complex interactions between ring particles and moons, observed Neptune's supersonic winds, the fastest in our solar system, provided the first direct measurements of interstellar space, offering insight into the environment beyond our solar system, a tribute to the scientists and engineers behind Voyager. The Voyager program is not just a triumph of technology, but a testament to the dedication of the scientists, engineers, and visionaries who made it possible. Many of those who worked on the project in the 1970s never expected it to last this long. Decades later, their work continues to shape humanity's quest for knowledge. Final thoughts: Voyager's place in history. As Voyager 1 moves deeper into the unknown, it carries the dreams and ambitions of humanity with it. It stands as a symbol of our relentless curiosity and our drive to explore the cosmos. Whether or not it is ever found by an alien civilization, Voyager 1 will forever remain one of humankind's greatest achievements, a silent witness to the infinite expanse of space. The journey of Voyager 1 is far from over. Though its instruments may one day fall silent, its legacy will continue to inspire future generations of explorers, scientists, and dreamers who look up at the night sky and wonder what lies beyond. Decades of groundbreaking discoveries, from the first close-up views of the outer planets to the first direct measurements of interstellar space, have shaped our understanding of the cosmos. Perhaps most importantly, Voyager 1 and Voyager 2 each carry a golden record, a time capsule containing greetings, images, and sounds from Earth, intended for any intelligent extraterrestrial beings that might one day find them. The record includes music from various cultures, spoken greetings in 55 languages, and sounds from nature, such as thunderstorms and whales' laughter. The final journey. As our power dwindles, the Voyager probes will gradually go silent. Scientists estimate that by 2030, the spacecraft will no longer be able to send data back to Earth. However, even after they stop transmitting, they will continue drifting through the cosmos for millions, if not billions, of years, carrying their valuable messages from the human race. It is unknown whether an alien civilization will ever discover one of these ancient spacecraft. If they do, they will find a snapshot of our past and present, a record of where we came from, and our hopes of reaching beyond the stars. For now, Voyager 1 and Voyager 2 remain our far-flung ambassadors, venturing deeper into the cosmos than anything made by humans in history, once again pushing the boundaries of exploration. The role of gravity assist. Voyager 1 and Voyager 2 embarked on their mission to investigate the outer reaches of our solar system. To reach these distant destinations and gather crucial data, the spacecraft needed more than their own propulsion systems. They required a boost. Gravity provided that assistance. Imagine the two courageous rockets, Voyager 1 and Voyager 2, setting off on their grand tour of the solar system. Rather than relying solely on their engines, they engaged in a celestial dance with some of our solar system's heavyweights. These planets, with their massive gravitational pulls, slingshot the spacecraft on their way. This technique allowed them to conserve valuable fuel while gaining the necessary speed to visit multiple destinations. Delving into the basics of gravity assist, also known as a gravitational slingshot, we see that this maneuver transfers some of a planet's energy to the spacecraft as it passes by. Picture Voyager 1 approaching Jupiter, a massive gas giant with immense gravitational pull. With meticulous precision, Voyager 1 passed Jupiter at the perfect angle and speed, allowing Jupiter's gravity to accelerate it to a higher velocity, giving it a substantial boost. Gravity assist maneuvering requires exceptional precision. If Voyager 1 had approached Jupiter at the wrong angle or speed, the slingshot effect could have led to a disastrous deviation from its intended trajectory. The level of accuracy required was overwhelming, yet the brilliant minds behind these missions successfully executed multiple gravity assists, propelling the Voyager spacecraft on an incredible journey through the solar system. Voyager 2, for example, used gravity assists from Jupiter and Saturn to reach Uranus and Neptune. These celestial maneuvers were fundamental in making the Grand Tour possible. The Voyager missions owe much of their success to these gravity assists. Eventually, Voyager 1 reached interstellar space, with Voyager 2 following closely behind, all thanks to the precision of these maneuvers. The concept behind gravity assist is simple, yet its execution is incredibly complex. Voyager 2's Grand Tour required such a high level of precision that missing even one of these slingshots could have resulted in mission failure. However, the dedicated individuals behind these missions were determined and unwavering in their pursuit of knowledge. The Deep Space Network. While gravity assists played a crucial role in space exploration, another important aspect ensured the Voyager mission's success. The Deep Space Network, DSN. Often regarded as an interstellar telephone line, the DSN kept us connected to our brave explorer probes as they ventured into the great unknown. Though less visible than the spacecraft, the DSN is equally vital. It consists of massive radio antennas strategically placed around the world, with locations in California, Spain, and Australia. These enormous dishes, ranging from 26 to an incredible 70 meters in diameter, act as powerful amplifiers, enabling communication with spacecraft traveling beyond our planet. The Voyager probes, equipped with cameras, sensors, and instruments, serve as our eyes and ears in the vastness of space. To interpret their data and provide new directions, an effective communication system was essential. This is where the DSN came in. Imagine Voyager 1 on its route to the solar system's outermost regions, transmitting a message back to Earth. A faint signal, traveling at the speed of light, crosses the immense void of space. By the time it reaches Earth, it is merely a whisper. However, the DSN's massive radio antennas are ready to capture that whisper. They lock onto Voyager's weak transmission, process it, and transform it into data that scientists can analyze. But the DSN doesn't just receive signals, it also sends commands. The Voyager missions are active undertakings, requiring scientists and engineers to adjust trajectories, redirect the spacecraft, or modify instruments. The DSN transmits these commands, sending them across space to reach Voyager and guide its journey. It functions as a two-way conversation between Earth and the farthest human-made objects in the universe. One remarkable aspect of the DSN is its unwavering operation. It works tirelessly, continuously monitoring for signals, acting as an unblinking eye on the cosmos. This ensures that we remain connected to our space probes, even when they are billions of miles away. The Voyager mission stands as a testament to the power of teamwork and innovation. While the spacecraft embarked on their magnificent journeys, the DSN ensured they were never truly alone. It bridged the distance between our planet and the unknown, enabling us to explore the outer planets and venture into interstellar space. A mysterious anomaly. But did Voyager 1 experience a malfunction? Or was something else at play? Throughout its incredible 45-year journey, the Voyager 1 probe has remained remarkably resilient, steadfastly executing its mission. However, In recent years, scientists have observed performance irregularities, sparking interest and speculation. Currently, Voyager 1 is transmitting unusual messages back to Earth, creating the impression that it is uncertain about its exact location. What makes this even more puzzling is that the initial data received for Voyager 1 was unintelligible and indecipherable, causing confusion among NASA scientists. Upon investigation, researchers discovered that the culprit behind the distorted data was the Attitude Articulation and Control System, ACS. This onboard system is responsible for evaluating and reporting the spacecraft's orientation in space, ensuring its antenna remains pointed toward Earth. The issue surfaced when the software unexpectedly switched to transmitting telemetry data through a broken onboard computer that had been dormant for years. NASA engineers successfully resolved this anomaly by instructing the spacecraft to resume data transmission through the correct computer, restoring uncorrupted transmissions from Voyager 1. However, the unanswered question remains: why did the spacecraft switch to the malfunctioning computer in the first place? While NASA scientists hypothesize,